Have you ever seen a giant number in your code and thought, what even is this? Is it 10 million, 100 million, or just a random string of digits? You start counting, one by one, just to figure it out. But what if I told you there's a simple trick that makes numbers in your code much easier to read? Many programming languages offer features to make numbers clearer, while some still don't. I went through 50 of the most popular programming languages to find out which one help you write more readable numbers, and how you can use them in your own code. In natural languages, we make numbers more readable by inserting numeric separators between digits. Different regions format large numbers differently. It would be nice to use a similar separator for numbers in your code, right? I checked 50 top programming languages and found this. Many modern languages support numeric separators. Even older languages have recently added the feature. But not all languages support numeric separators. Of the 50 languages I checked, 16 do not support them, while 34 do. It is quite surprising that Fortran, MATLAB, and R do not yet support numeric separators, especially since they are heavily used for scientific computations and data analysis. On the flip side, it is not surprising that Bash, PowerShell, and Awk don't support them, as they are primarily designed for command line scripting, not complex calculation or software development. Among the languages that support numeric separators, we have some of the most popular and widely used ones, like C, C++, C#, Go, Java, JavaScript, Python, Rust, and mobile development languages like Kotlin and Swift. Many of these languages added the feature in later versions. Even C, which dates back to the 80s, only introduced numeric separators in 2024 with the C23 version. So what do these languages use as numeric separators? Well, all except C and C++ use the underscore symbol. C and C++ are the two outliers, using the tick or apostrophe symbol instead. Don't ask me why. Numeric separators work with different types of numbers, including floating point numbers and various number formats like binary, hexadecimal, and octal. The cool thing is, the separator don't always have to be placed at thousands. You can use them to group digits in any format for better readability. Some languages don't support consecutive or trailing separators. For example, most languages like C, C++, Go, JavaScript, and Python allow only a single numeric separator between digits. But some languages, like C#, Dart, Kotlin, Java, and Haskell, let you use consecutive separators. This can help when you're working with really large numbers, making them easier to scan at a glance. Others like Rust, Swift, and NetWide Assembler even allow trailing separators. Don't ask me why. But hey, if you would like to make your code more quirky, why not? Use numeric separator to improve readability. But don't go overboard. Stick to grouping by thousand to maintain clarity. Avoid using strange formats unless your code is specific to a region or context. For example, the Indian number system. The goal is to make your numbers easier to understand at a glance, not harder. So keep it simple. What if your language doesn't support numeric separators? Well, exponential notation can sometimes help. Exponential notation expresses large numbers as a product of a number, called the mantissa, and 10 raised to an exponent. This format is supported by most programming languages, so it's a great alternative when separators aren't available. Among the 50 languages I checked, only Bash doesn't support exponential notation. For all the others, the notation is mantissa e exponent. But here's the catch. If the number isn't a clean power of 10, it can still be hard to read. For example, writing 5,000,001 in exponential form doesn't make it much clearer, since the mantissa can still be difficult to pass at a glance. In languages that support numeric separators, you can combine the two, numeric separators and exponential notation, for maximum clarity. Now, there's another trick that works in all 50 languages. Constant folding. Let's say you need to specify a timeout duration in milliseconds for a function. You could write 1,800,000, but that's a mess. Is that 18 minutes? 30 minutes? You will have to stop and think. Instead, break it down. Now it's instantly clear that this represents 30 minutes. Instead of writing a giant number directly in your code, break it down into meaningful expressions, especially when passing constants to function calls. And thanks to constant folding, the compiler evaluates this at compile time, so there is no performance cost. For interpreted languages, the cost is negligible due to runtime optimizations. This is especially helpful when working with units we don't use daily, things like milliseconds or bytes. When working with a unit that isn't intuitive, breaking it down into meaningful expressions makes your code much easier to understand at a glance. So what did we learn? Numeric separators, exponential notation, and constant folding are all tools that make numbers more readable. Many modern languages support numeric separators, so use them when you can. If your language doesn't, exponential notation might help. And when dealing with unfamiliar units, take advantage of constant folding to make your numbers self-explanatory. Thanks for watching. I hope this video helped you write cleaner, more readable code. If you found this video useful, don't forget to like, subscribe, and hit the bell for more tips. And check out the description section for extra resources to help speed up your coding journey.